In the previous sections, we have encountered several different quantities with units. For example, a distance of 979.0 meters, or a time of 86,400 seconds. In cases like these, it's the size of the quantity that matters. These are examples of scalar quantities, where the quantity is described by a single number with appropriate units. Other scalar quantities would be temperature and mass. And while many quantities in physics are scalars, many others fall into another category where the magnitude or size of the quantity is only half the story. Consider the figure below, which depicts a car that has moved 2 kilometers along a straight line. To just say that the car has moved a distance of 2 kilometers is an incomplete description of its motion, since this provides no information about the direction the car has moved. A complete description must include the direction information. For example, a complete description of the car's motion would be a distance of 2 kilometers in a direction that is 30 degrees north of east. A quantity that requires both a magnitude and direction to completely describe it is known as a vector quantity. The colored arrow in our car example represents a displacement vector, since it shows how the car has been displaced from its original position. We use arrows to represent vectors, since the direction of the vector is given by the direction the arrow points, and the magnitude or size of the vector is determined by the arrow's length. For example, if another car were to move 4 kilometers from the starting position, the length of its displacement vector would be twice as long as the one for the first car. By convention, when different vectors are drawn to scale, their length will be directly proportional to the magnitude of the vector. We will encounter many different vector quantities throughout the course. They are very important in physics. Forces, for example, which we will begin our study of in Chapter 4, are vectors, and they can change the motion of objects, including their speed and direction. Remember that the fundamental distinction between a scalar and a vector is the characteristic of direction. Vectors have it, and scalars do not. In the course of our problem solving, we may need to add or subtract vector quantities. Before we take a look at this in the next section, we have one clarification on notation. In your textbook or ebook, vectors will be written in boldface with an arrow above them, and scalars will be written with italic symbols. A displacement vector, for example, would be written as a equals 750 meters due east, where a is the vector symbol. The magnitude of this vector is just its length, which is a scalar, without reference to direction. Therefore, the magnitude is written as a equals 750 meters, where now the a is written as an italic symbol without the arrow. Now let's see how we add and subtract vectors.